currently banking stage does not keep up if we are receiving that much traffic. We will basically only receive into the scheduler some fraction of those packets and then have an incomplete view of all the transactions that we've received. We can only schedule off of those ones that we've deserialized and inspected to see which ones are the highest priority. And one of the main bottlenecks there is just the deserialization we use for our transaction type.
Scraping Bits is brought to you by the following sponsors. MEV Protocol. Maximize your ETH staking value with MEV ETH, exclusively on mev.io. And Composable. Execute any intent on any chain, coming soon to mantis.app. That's mantis.app. And Fastlane Labs, the only MEV and intent-centric team that has a daily deodorant application rate of over 68%.
GM everyone, my name's Dagachi, the host of Scraping Bits, and today, with another Anza participant, Andrew Fitzgerald. GM, sir, how's it going?
Good, yeah, thanks for having me. Excited to be here.
Excited to have you on. I'm sure a lot of people are going to enjoy this episode. Highly anticipated. Just for the people that aren't familiar with you, who are you and what do you do?
So I'm an employee at On, and my main focus is working on banking, basically all things banking stage. My big pet project has been the transaction scheduler, the new one, not the old one.
1.18.
Yeah, it's becoming an option in 1.18. It'll be the default in 1.19 or 2.0, whatever we end up calling it. And yeah, super excited for that to get out to mainnet because it has a lot of very nice properties.
Very excited to talk about this. And just before we do, how did you get into this position? What were you doing before? Give me your lore, your history.
Yeah, sure. So I got my PhD in nuclear engineering at the University of Michigan, and obviously not a very traditional background for people doing crypto stuff. But I was working on an HPC neutronic simulation tool. And so a lot of the stuff I was doing was just optimizing a code for performance. And about half the work I was doing was, coming up with new methods for simulation, and then half like implementing and optimizing. I found myself kind of enjoying that second part of it more. And so when I finished my PhD, I just said, screw it, I'll go into finance, make more money, and just be a software dev. So worked at a trading firm for almost 3 years, and then a recruiter reached out to me about a position at Solana Labs. Sounded interesting. I was already somewhat crypto interested. Hadn't done any actual blockchain dev, but I was trading meme coins back then. So I joined Labs. Been there since till we moved on back in December.
What a crazy career switch from nuclear to finance and then to crypto, straight degen.
Yeah, it's actually surprising how many of the nuclear PhDs and STEM PhDs in general go into finance.
Yeah, I think usually the sciences just don't make that much money. So, and finance is just where it's at money-wise. So it just makes sense to switch over.
Yeah, I was offered a postdoc position for $35,000. I was like, maybe this isn't the right path for me.
I mean, very interesting to do that stuff, but you need to join the dark side to make the real money.
Yeah, it was definitely super interesting work. I do miss it at times, but yeah, it didn't make sense lifestyle-wise.
Yeah, definitely. I feel like you gotta mix science with engineering to at least make it a startup in some sense to actually make money through that cool stuff. Or a research lab, I don't even know, really. Anyway, so you joined Labs, right? How did you get into actually doing the scheduler and the banking stage? Why did you choose these specifically, and why not consensus or the voting areas? Why this?
It's actually kind of funny. One of the engineers who interviewed me basically gave me the scheduler design problem as an interview question. So when we were talking about it, I was, very interested in it. It just seemed like an interesting problem with NP hard. So it's there's no set way to do this. It's, very open to using heuristics to optimize.
Right.
And everything's always changing. So it's just always super interesting to work on that sort of problem. And then when I joined, I realized oh wait, they're actually working on this. So I just asked him hey, can I do that? And I ended up just basically taking that on as a project after working at Labs for a few months because I needed to get somewhat familiar with how the rest of the system worked first.
Right. Interesting. So you're oh, this is my interview question. Let me just continue doing that interview question.
Basically.
Okay. So you have to rewrite the entire scheduler. So let's break it down. What actually is the scheduler and the banking stage before we get deep into it?
Sure. So yeah, people have always like referred to what's currently there as a scheduler, and I kind of don't like that because I don't think it is a scheduler. Right now, we basically have like 4 threads that just independently pull from a channel coming
Right.
from like the sig verify stage, and they're all just sort of.
What's the sig verify stage as well, by the way? Sorry.
Oh yeah, sure. It's like packets come into the network through like Quick, and then we send those packets onto a stage called sig verify, and it basically does some sanity checks that these packets are transactions. And then once it knows that like, hey, this is probably a transaction, then it will check all the signatures, like validly signing that the message.
Right.
That way, by the time they get to banking stage, we know like, hey, these, we don't have to verify the signatures there because it's a fairly expensive operation.
That makes sense.
And yeah, sig verify uses like a bunch of threads to do that in parallel because it's relatively easily parallelizable.
Okay. And then what happens after that? You go to the banking stage.
Yep. So banking stage will then, depending on what time it is. So like if you're not the leader, you will probably be just like buffering those packets and forwarding them to who is the leader. And then if you are the leader, you will basically try to choose which ones you want to try to execute. Oh. And at least how it currently works, we have 4 banking stage threads, and they each just pull off that channel of sig verify, put them in a buffer, sort them by priority, and they just try to grab like the first 64 non-conflicting transactions. Non-conflicting, I just mean like the read-write locks. Like you can't have 2 transactions like writing the same account in the same batch. Then they just will go through some checks, make sure no other thread is touching that account, grab the lock for that account, make sure we can fit those transactions into like the block space, actually execute them, and then we record them into the POH stream, and then commit them. And then when we commit them, I think they get sent out over a broadcast stage.
Okay.
Which just uses Turbine to propagate those to the rest of the network.
And you say sort by priority, and how do you classify priority there?
Yeah, that's a good question. So it used to be just like a FIFO queue, and then sometime around when I joined, there's this concept of priority fees, and there's this CU price, which is just like, hey, how many LAN port or micro LAN ports per CU are you willing to pay to get this transaction executed? And so the old banking stage just takes that number, which is like specified in an instruction on the transaction.
Oh, okay. So if you wanted to be number 1, you could just max that out.
Yep. Yeah, and you would have to pay more for that.
Yeah, true. But I don't imagine anyone else would be maxing that out. Well, maybe now they would. But there was also an interesting thing. I think I spoke to someone else about like MEVs, basically MEV bots not paying any priority fee at all. And they were still like winning. I'm not sure why, but does that ring a bell by any chance?
It depends. Like there's a lot of like edge cases in the current banking stage where we have like these 4 competing threads that can just like let lower priority transactions sort of jump the queue if they just so happen to be the top priority in that thread. So like right now each thread basically doesn't have a view of what other threads have in terms of transactions, so it might be at the front of its own like local queue.
Okay, so it's like a race condition.
Yep. Yeah, and that's sort of like the main motivation for having like a separate scheduling thread. And all the scheduling thread does is just have a global view of what that priority list should be.
Right. Okay,
and then, I send work to the worker threads, obviously.
And you said the first 64 transactions, also, are they all being pushed into different threads themselves, or is it like each 64 transactions is pushed into a new thread, or is it shared between them all?
It's like each thread has its local buffer. It will grab like the first 64 non-conflicting transactions, and then it will execute those 64 transactions, up to 64 transactions in serial.
Okay. How does it check if it's non-conflicting? Are they they're not being shared at all, so it would be like 64 and then the 128 and then continuing. Well, 64, then the next 64, then the next 64, and they're all split into different threads.
Oh, no, it's like we've got like 4 threads. This is where drawing like helps. We've got like 4 threads. Each of them have their own buffer.
Okay.
And then we use this thing called, we basically have like multiple iterators, 64 of them into each buffer. And they like start at the front and then march forward to create batches of up to 64 transactions. And then each batch is just executed on that thread. They're not like going to another thread for execution.
Couldn't one batch actually be executed faster than other ones?
Yep. Yeah, they're all just running as fast as they can. So like executing the batch on thread 1 is not going to wait for like execution to finish on thread 2.
So what would actually cause one thread to execute faster than another?
Just like simpler transactions, right? Like something like a simple transfer does not take as much time as a swap on Jupyter.
Okay, because it's going from the emulator, right?
Yeah, like the Jupyter stuff would have to like load that program and then boot up the VM and then send it through there. There's like a lot of overhead in terms of like executing BPF stuff. Not a ton, but it's more than just native programs which are not doing that.
Yeah, definitely. Have you ever heard of like the mutex lock game where people are just locking each other's programs? I guess if a thread is looking for non-conflicting transactions, then if it's already in one thread, another thread wouldn't grab it because it's already being used by one. Is that correct?
Yeah.
Okay.
Yeah, that's how it works in like the current banking stage.
Right, I see. Okay, that makes sense. Is that not in the new one at all?
Yeah, so like the new one basically keeps track of which threads have which locks. And so it's only ever going to send work to a thread if that work doesn't conflict with any other thread.
Okay, so if I was an MEV bot and I see my competitor use, N accounts and like one of the elements I actually just use as a lock in mine, it doesn't do anything, it's just locking it, and I'm processing mine because I'm before them, then their transaction won't actually be processed because I've held that lock, right?
Yeah, and I think right now that's a big issue in like the old banking stage because you don't necessarily have to pay more than them.
Yeah.
In the new, right, you can get lucky and just like grab that lock and then that prevents them from doing anything.
Spamming that, and so they never actually get it, right? That makes sense.
In the new banking stage, as long as like both packets have arrived at the scheduler, then like whoever is paying more priority fees, it's like going to get that.
That makes sense. Okay. I guess the fees aren't even that expensive either. So it's if they both send the same amount of priority fee, who gets it? Is it just a race condition again at that point?
I think it would be at that point like default to whoever like arrived first. So it's like a time race rather than. I actually don't remember. It's going to depend. I don't remember how that's resolved exactly.
First in, first out, probably. But if it's sorted by that, I guess it would be sorted by maybe the transaction hash, like the size is bigger than another one. I'm not sure. Or like time of inbound. That would make sense.
Yeah, I think it's just time. I'd have to look. We use this min-max heap for like sorting the priority order. I just don't remember how that handles like things exactly match.
Okay. So what were the major flaws in the current bank, and how did that architecture change? What did you change for the new scheduler and banking stage? What was the old one? What were the problems? How did you fix it? Are there any more problems?
Yeah, so the old banking stage, as I mentioned, had sort of these 4 independent threads. None of them knew what the other ones were doing. And so siloed. Immediately we have this sort of locking problem. If we've got a bunch of, let's say there's like an NFT mint going on, everyone's trying to get like trying to get that NFT first. So all of like the highest priority transactions in those 4 threads buffers are all going to be touching the same state. And then it's just like a race condition onto who wins that. And so we have like a lot of account in use errors where basically we're not executing these transactions because the account is being used by another thread. It's just pretty inefficient. And then it's not clear, like, this was the next highest paying priority one, but when do I retry it? And that's difficult without having some way of knowing what the other threads have. And that's like a big issue with just the account locking. And then the other one is just there's no global view of priority. So none of the threads know what the actual highest paying transaction or like the most valuable transaction to pack is. So we could end up in a situation, where just by chance, all of the very high priority transactions end up in one thread and a bunch of low priority ones end up in another thread. Thread with the low priority transactions, it's still going to go through those and pack a bunch of, basically non-valuable transactions, and that could fill up our block. And then, we're not selling to the people who are paying us the most. So inefficient from the leader's perspective.
When a thread grabs a lock, what happens to that transaction that was using that same account? Is it just pushed all the way back to the bottom, or what happens?
Do you mean if it fails to grab the lock?
Yeah, exactly.
Yeah, it basically, an old scheduler will basically just retry that transaction the next time we do an iteration. So it won't work again until we've gone through like the entire rest of the buffer.
Would it still be at the top of it, or would it be pushing other transactions in front of it though?
Yeah, I guess like logically it would then go sort of back to the bottom of the buffer.
Oh god.
Yeah, it's not great.
Yeah, okay. So what were the solutions that you did with the new scheduler?
Yeah, the new scheduler will basically, it has a global view of the priority because there's only a single priority queue.
Yeah.
So we always know like this is the most valuable transaction for me to pack in terms of reward per CU.
Okay.
So that's immediately better. But then we don't have this locking problem because we're keeping track of which of our threads have which locks. So we're only going to send things if they're not conflicting with other things. And then if there's a conflict, say like I sent some transaction one that touched accounts A and B to thread 1 and another that touched C and D to thread 2. At that point, I can't schedule some third transaction that touches B and C because it's conflicting like across threads.
Right.
And at that point, we will basically block on that transaction and not schedule anything that conflicts with it until we can schedule that one, if that's like the next highest paying.
Okay.
So it's sort of in that way, it's guaranteeing that we're respecting like the priority order in our buffer, never executing things out of order.
Okay.
Never is a strong word there because we like queue up work and we might have set things to be worked on and then a new higher paying transaction comes in. Obviously, because we've already scheduled that work, we can't unschedule it.
Okay, let's say you did a transaction with a priority fee of like 10. It's in one of the threads now, and I send a transaction that's 11. Will your one be processed before mine, even though mine is... It's like still in the thread, but your one will still be processed, right?
Yeah, basically once it's sent by the scheduler, it's in flight. We're not going to go back and stop that. We could definitely optimize there. I think there's some work that needs to be done there. But right now, that's how it works.
And then when it's processed, where does it actually go? It's building the block, right?
Yeah. So we have like a separate scheduling thread, and that's just sending these transactions to worker threads, which there are like 4 or more. And then those worker threads basically do what the old banking stage was doing. They, grab the account locks, just make sure that I didn't screw anything up in the scheduler, runs the normal checks, technical loads and executes, and then records and commits. And then recording goes into like the actual POH stream and then, broadcast those transactions out.
Does it record in like an iterator or is it all at once? Let me clarify that actually. So as you're processing transactions and they're being put into like, let's say this vector, are you waiting for the vector to be finished and no more being sent for you to finish the block, or is it continuously adding? So let's say thread A spits out a new one, thread B spits out a new one. It processes thread A's transaction as an iterator and then thread B's transaction right after, or is it like stacking them and then putting it all in? And is there any way that someone could actually change the order after the process in the scheduler?
So once it's been recorded, you can't change the order.
Okay.
Or it would be difficult because we broadcast that out already potentially. So we can't like say takesy backsies. But yeah, in terms of like, recording immediately versus stacking up, it's sort of a mix. So the scheduler doesn't schedule individual transactions. It schedules batches of transactions.
Batches, okay.
And these batches of transactions, we'll load and execute all of them and then record them as like a single mix-in hash into the POH. Basically, the reason I don't know the full context, but one of the reasons is that we basically have like this lock around the POH thread. And so we don't want to be grabbing that lock every time we have to process a transaction.
Right,
There's some overhead in doing so. So it's more efficient overall. I think when I benched, this is like 30% faster to do like batches versus individual transactions.
Right, got you. Okay, since you're doing batches, let's do the priority thing again. When you have a priority of 10, I have a priority of 11, your one's in the thread before mine, my one comes right after, your one's being put into this batch. Does mine go below yours even though my priority is higher? Or is the priority really just for those threads to basically select what to go first. It's not like actually in order of priority for the record.
Yeah, so we are not like, I think Anatoly's had this idea of basically enforcing priority on the order on the block and like sort of wait until all of the block is completed and then reorder things, post-completion. That is not what we're doing right now. The priority is strictly for the leader to attempt to like choose the most valuable transactions. It's still free to order them however they want. In your case, right now, because that first transaction was already sent off to be executed, it might have already been completed, and the scheduler is just not aware. Your transaction would still go after that. It would just go in the next batch.
Okay, got you. What are the challenges you kind of see or saw, or maybe you are seeing still, with actually building something that is efficient at like sorting transactions, processing them, especially with spam in the equation? So what are the challenges you kind of face with the spam? How do you think to deal with it or try to deal with it? Maybe it hasn't worked, maybe it has worked, just that kind of stuff.
Yeah, so one of the things that we'd noticed some time ago, we noticed this because of the banking trace data that we added in, which lets us inspect which packets were in banking stage that ended up not getting into the block. That's been super useful for like going back and seeing, why wasn't this block backed as efficiently? And after we added that, we were seeing on mainnet, there were these malicious spammers that were sending out a transaction with a high priority fee that locked a bunch of accounts, basically to block their competitors from accessing that state.
Yep.
And they had like an invalid fee payer. They couldn't pay the fee. And the old banking stage at that time was still like scheduling it first. And so it like basically let them take the locks and block their competitor. So we added in a bunch of like checks before we actually send things off to be processed. So we check before we ever take locks. So like, hey, this can pay the fees. We basically started doing a bunch of checks earlier on these transactions, and often we can do that, before we become leader. So like, if you can't pay the fee now, I'm just going to drop you. There's a high likelihood that you're still not going to be able to pay the fee when I do become leader. There's an off chance that maybe you had a funding transaction in there, but from my perspective, that's not worth the risk to drop you and keep more transactions that I know are more valuable. Is that going to make sense?
Yeah, because people do funding transactions. I didn't even know that.
I don't know of anybody doing that. It probably doesn't work. It probably doesn't work very well anymore. If anybody was, they're not doing it anymore because I would have screwed them over.
Yeah, I wouldn't imagine it working at all. If you just see like a standalone transaction that isn't paying anything, I don't know. It's a bit weird. I'm just saying. Yeah, the biggest problem is spam right now. The congestion issue, spam, of course, and then also like malicious adversarial congestion, which is the major issue at the moment. Do you think it's like a network issue, like a sorting of transactions issue, or maybe even the whole pipeline? What are your thoughts on that?
Yeah, I think it's a problem sort of in the whole pipeline. Actually, it's really interesting, the things I've been working on this week. A lot of it has been networking issues. The networking stack had a bunch of really inefficient spots, is my understanding. I'm not super familiar. And especially with relation to like the stake-weighted POS, there was bugs in there that made it not work as well. People were spamming like to open up new connections. That let them just get in their transactions, and they would spam a bunch of transactions to basically try to get first in one of these 4 independent banking threads.
Right, yeah.
So even just moving, I guess like other people have been working on these networking fixes, which helps reduce that on the networking side. But until we move to the new scheduler, there's sort of still this incentive to spam, because you might get lucky, end up on a thread where you're not conflicting with anything high in priority. So you get first and you win the race. Doesn't happen in the new schedulers. That really reduces the incentive to spam in terms of banking stage.
Mm-hmm.
I think there's also like pretty significant issues in terms of just our sort of pipeline throughput.
You're right.
The networking stack used to be, to my understanding, the bottleneck, or the major bottleneck. And with the recent changes, that is becoming less the case. And now we have bottlenecks in Sig Verify, and that can only do like, I forget, it's like 200K TPS is what someone told me recently. All those packets are feeding into banking stage, and actually currently banking stage does not keep up if we are receiving that much traffic. We will basically only receive into the scheduler some fraction of those packets, and then we basically have an incomplete view of all the transactions that we've received. And we can only schedule off of those ones that we've sort of deserialized and inspected to see which ones are the highest priority. And I've been working a lot with another Hanzo dev, Alessandro, who done a bunch of like profiling work. And one of the main bottlenecks there is just the deserialization we use for our transaction type. It does a bunch of like internal allocations. So I've been working on this week for a bunch. It's quite interesting. There's this version transaction type, and it has like at least five internal vecs that it has to like allocate on the heap. And every time you do like a heap allocation, you're basically risking this really long call, or has to maybe do some like bookkeeping work in whatever allocator you're using. And most of the time that's fast. It's just going to like some thread local cache of memory that I think JMalloc uses. But occasionally, and particularly when like the memory pattern doesn't fit in with like recent accesses and allocations, then you're sort of risking these long calls. And it just take like 10 milliseconds sometimes to do like a few hundred transactions. And it's just ridiculously slow. Occasionally. Most of the time it's fast. Basically, yeah, I've been working this week, like that's like a huge bottleneck in banking stage. And we're spending like 30 or 40% of the time just deserializing these transactions.
Oh wow. 10 milliseconds is a long time when the block is 400
exactly. And I've been working on like this pet project, and I don't know if other people will go for it because it uses unsafe Rust, but like all of that's super unnecessary. We have this like serialized packet. We can just calculate offsets into it. That is extremely fast. I can do it in 20, 30 nanoseconds per packet. Okay. And so basically what used to be taking for 200-300 milliseconds to deserialize like 90,000 transactions, I can do that in 2 milliseconds now.
What was the solution for that?
Basically just creating like a new transaction type that doesn't do these internal allocations.
Oh, okay, got you.
So it's kind of like a big change because we'd have to change our transaction type everywhere. So I don't know if other people are going to go along with this quite yet.
Oh yeah, you have to change
it's like a super recent development. Yeah.
Interesting.
But yeah, I think that's like a huge problem is basically if banking stage isn't keeping up with the packet signal if I'm sending it, then banking stage has this sort of incomplete view on what transactions it should even schedule. And there might be, a really juicy transaction in there that pays me a ton of fees, and I'm just not seeing it because my deserialization is so slow.
I feel like you don't even have to do full transaction checks either. I mean, I could be wrong, but even just like simulating half of it or partially to some degree, maybe there are heuristics that.
We don't simulate them. We don't simulate them like when we're receiving.
Oh, okay.
Just like not doing like the full transaction check.
Wouldn't you simulate them in the banking stage though?
We just execute them in the banking stage because like it's the same process of simulation, except at the end we like commit those results back to the accounts database.
Oh, okay. So when do you simulate in the pipeline?
The only place we simulate in the pipeline is like on RPCs. Like we don't actually do that in the validator.
Oh, I don't know. Okay. Interesting.
Yeah, so I think Jito does simulation in like their block engine, but that's not like part of the Agave client.
I did the one with Seg the other day.
Okay, cool.
So I was talking about all about that. If you were, do you think the execution is actually slow at all?
Yeah, execution is definitely slow in some aspects, and I think we can improve things there. I'm not familiar with like the VM stuff. Some of it comes down to just like app developers. If you're not writing a smart contract that is efficient, then there's no way I can execute that efficiently.
Yeah, that makes sense. Doing.
But at the same time, like per CU, I think that we can probably do things faster than we are currently.
When I was speaking to Joe, one of your coworkers, he was working on runtime V2 for Agave, and we talked all about that. And I think it does seem very inefficient because you are spinning up and down a new VM each time. I think for every instruction, not even every transaction, it's for every instruction in the transaction. And yeah, as you said, like if something is super convoluted and there's just like a lot of shit happening, I mean, you could probably just like rewrite it. Maybe if you want to be super fast, maybe you have something that caches that program but actually optimizes it automatically so it's faster. If it, like, let's say like a Radium program, if that's just used all the time, that shitty program, I'm not saying it's shitty, but like let's say it is for this purpose.
Yeah, I think I get what you're saying.
Yeah, then you optimize it and cache the optimized version so it runs faster.
Yeah, I don't know if that's like technically possible. I know we do like some sort of like compilation and like sort of these compiled like programs, which I think is effectively that. I don't think it's going to do like much optimization though. I don't think it's going to like change the actual like core logic, the BPF instructions we're saying to do.
Well, I guess if you like customize the bytecode as much as possible, then there's less to execute.
I think the issue with doing something like that, I think it's technically possible. Like you're just saying like, hey, everyone's using Radium. Let's write our own like Radium version that's more efficient.
Exactly. Just optimize Radium itself. It does the exact same thing. It's just less shit to actually execute.
Yeah, I think the main issue with like an approach like that, one, it's like a ton of work, but two is if it's using like a different amount of CUs, then that can lead to like consensus differences. So unless like all of the clients, so like us and Firedance or Keto, we're all using like the same optimized version, then like we're gonna end up with something that fails consensus.
Maybe an optimized version would be good for simulations then.
Yeah, like.
But is that really the
there's enough? Yeah, I don't know. I think if we want programs that are faster, it's sort of down to devs a little bit to optimize their own stuff. You know, we can make the VM faster in general, but we shouldn't be picking winners.
No. Yeah, that makes sense. Okay.
Yeah, I'm trying to think. And actually, yeah, an interesting aspect of like the new scheduler compared to the old one. The old one, or the old banking stage, just went off of that CU price in terms of like priority. But the new scheduler it sorts by like reward over transaction cost. It's like inherently, it's sort of prioritizing people who request fewer CUs or use fewer CUs.
Oh, really? So like optimization is actually mattering now.
Yeah, it's like actually incentivizing people to optimize their apps.
Oh, hell.
They optimize their apps, they can like pay the same fee but get much higher priority.
So the less CU, the actually higher priority in the new scheduler.
Yep.
Okay. Bring in the optimizers.
Yeah, I'm excited to like see if that has sort of like, it's not gonna like change overnight as we like roll out the scheduler, but it'll be interesting to see maybe how that evolves over time.
I was thinking of this before because coming from ETH as an optimizer, like writing raw bytecode, it's the benefit obviously with gas, but if you think about it, if there's a limited amount of shit to store and also simulation wise and execution, it's always just better to have less because there's just less overhead to actually compute. So this is like another benefit, incentivizing a bit more to actually nerd snipe some optimizers like myself.
Yeah.
It actually has not marginal benefit, but like major benefit now. So that's fantastic. Great change. Yeah. Get this man
excited about that one.
Give him a promotion, guys. Come on. But I think like assembly in Rust is actually such a great skill as well. So like people that will learn this will get so good at Rust and like understand a lot better. So I think it's like a massive W, honestly, not just for Solana, but for actually onboarding devs into low-level Rust engineering as well.
Haven't written like any smart contract code myself, or like nothing, not like a simplistic example. Like I don't know too much about like how to optimize it, to be honest.
Oh, okay. That's like my entire background.
Okay, gotcha.
Yeah, optimizing, security, fuzzing, all that stuff. That's kind of my bread and butter.
Yeah, it seems like fun work. I haven't too busy on other shit.
I love virtual machines as well, emulating them, simulating stuff. Like Ethereum was very easy to do. Solana seems a lot more complex because it's registry based, because it's Rust, but still fun nonetheless, right? That's sick though. Is there any other like giant optimizations you did that people should be aware of for this upcoming scheduler?
Not that I can really think of off the top of my head.
Yeah. Okay. So there's like the threads changed. This CU's changed. That's really cool. I like that. Is there anything you're seeing like other validators do that differ from Agave or the Solana Labs one? What are they really prioritizing in these that you see? I guess like a lot of validators are trying to do like MEV or like voting MEV, I guess, optimizing the voting part. But what do you see like the most efficient, low-hanging fruits for the validator are?
That's a good question. I think that there is like a lot of vote optimization stuff that could be done. I don't know too much about how we vote currently, but it seems like we've seen people been or have been making like changes to how their validator is voting to get more like vote credits.
Yeah.
Some of that's sort of dubious at best, and that's sort of and then Tetsu's like timely vote credit proposal to incentivize people to like keep consensus alive. Yeah, I think. Well, yeah, if everyone like delays their voting and just doesn't vote because they're waiting for the court to be selected, yeah, then we're just kind of going to kill ourselves. So yeah, I think that there's like proposals like that which can help address this. But yeah, I think there's like this sort of some issues with like when we choose to fork when we're a leader versus not. I think there's probably too much waiting right now. And yeah, again, I'm not super familiar with this. I know another engineer, Justin Starry, is working on like improving some of this logic. And I know that he's got a few work in progress things to sort of improve the skip rate here of the validator, improve that and reducing that.
Time sensitive, time weighted as well. So the faster you do it, the better it is, rather than waiting for other people, like other votes and all that other shit. I think that's pretty important. Yeah, I think the scheduler was amazing. That's where all the kind of shit happens, because all the mutex locks. Is there like mutex? I mean, programming with mutex is quite difficult anyway. At least doing it efficiently in a blockchain like this, where the lock matters. Like it actually changes whether you land or if you don't land. What are you seeing like any other kind of adversarial games, or is anything interesting in the current scheduler banking stage, and whether that's might happen in the new one that you've built?
So we have seen some things around like abusing the fact that like the old scheduler just uses its raw CU price. But again, that's not really an issue in the new one because it has this reward over cost priority or prioritization instead. Yeah. Other than that, not too many things that I can think of off the top of my head.
Okay. And let's say people wanted to continue optimizing. Is there anything you just didn't optimize in the scheduler banking stage that you would like to future wise? Anything that kind of sparked your interest you just didn't have a chance to? Anything that seemed important?
Yeah, I mean, it's definitely like still a work in progress. There have been like recent PRs, so an issue sort of going back in time a little bit. People don't make accurate CU requests, and generally we've seen like that people will request like 70 times more than they need. Like, ridiculous like that. It's insane in some cases. And so the old scheduler, basically there's no trust in like what CUs you're requesting. And when I wrote the new scheduler, we basically were operating off that assumption that these were not accurate at all. And
why are we not accurate?
Just because people request like 70 times more in some cases than they need.
Got you.
So basically it's like I can't really trust these requested CUs. And the initial scheduler was written with that sort of assumption in mind. But then as I've like made this change to do the reward over cost prioritization, we've seen that sort of ratio come down, and the values that we're seeing in like the transactions that end up making into the block are much lower. Worst case, people are on average like requesting like 5 times more CUs than they need, which isn't so bad. And so like I've recently been doing some load balancing stuff using the CUs rather than just like transaction counts, which means that like basically work is spread more evenly across the threads. But again, like it's sort of recent developments, because until recently we didn't know that we could rely on these CUs at all.
Why does having 7x the amount of CUs that you really need actually matter?
I don't have any idea of like how long they're actually going to take. You can take anywhere from 0 to the full amount of those CUs. So it's like that's not useful to me to load balance. Right? If I'm trying to schedule like similar amounts of work to each thread, it's not useful if my range of times for each transaction is like 0 to 5 milliseconds. That's too big of a range to like make a useful estimation off of.
Right, got you. Okay, because like I guess there is a time associated with execution with the amount of CUs. What was kind of like your estimation of what's like the average amount of CUs? Like, was it 4?
I think it's like 30 CUs per micro is like the cluster average.
Okay, 30 CUs per micro.
I think that's like an out of date value. Even with the new stuff in the new scheduler, I'm not like using that value. I'm not going to like associate time estimate with like the CU. That could be inaccurate still, but more just trying to load balance like how many CUs I send to each thread.
Okay, so you've got like maybe a max amount for each thread, and you're like, okay, this is kind of similar. Let's batch them.
Yeah, it's basically like, hey, I don't want to create a block that's like, hey, I accidentally sent 30 million CUs to one thread. Let's
right, and then it's just stuck there.
Yeah, keep it somewhat parallel.
Way longer.
Yeah.
Okay, interesting.
So yeah, and just excited about like some of the longer term SIMDs that we can optimize the scheduler after.
And what are you looking at there?
I talked about this a little bit earlier. Each of these batches that we send to the workers, there's like a constraint in the protocol right now that each of them, like, it's up to, let's say 64 transactions, but all of those transactions can't touch like any of the same accounts. If they did and you like put that into your blocks, then it would be like a protocol error. And there's no real reason for that. So like we recently had SIMD 83 accepted, removes this constraint and just says, yeah, put whatever transactions you want in an entry, and then if they do conflict, they need to just be executed in that order. Yes, that makes like a lot more sense. It also can like help the scheduler be more efficient. So if the top 10 paying transactions are all conflicting, put them in a batch, send them all there. They'll be executed in that order. I don't have to like send them in 10 separate batches and potentially slow them down with other work between them.
Interesting. Okay, and this is like final question. Where do you actually see Solana going? If it's something bad, how do we redirect it into the right direction? Yeah, and I guess like also MEV on Solana. Where do you see that going?
Yeah, I don't really have like big concerns about the direction Solana's going right now as like a whole. I think the general direction is good right now. In terms of MEV, I think it's hard to say. There's like different kinds of MEV, and I think some of it is like a net negative and some of it's fine.
What kind is a net negative? I obviously the locks one and the spam, but is there anything else?
Yes, I mean, I think we saw this recently with Jita. It was like users were getting sandwiched because of the like mempool, and searchers would just like sandwich user transactions.
Oh yeah.
I think that's like, I think Jita made the right call in turning that off. But there's probably entities out there who are, I guess, less respectable than Jita, let's just say, and willing to do that and offer that service to their searchers.
Oh, that's okay. Fair.
So just because Jita has disabled it doesn't mean that someone else might call on. But personally, I think that's like a net negative for the ecosystem. If users are sort of afraid of getting sandwiched every time they send a DeFi transaction, they're just not going to.
Yeah, definitely. Or they just won't send it to that validator, and then there'll just be a skipped block, basically.
Yeah, they might like avoid certain validators, which I think that
yes, at that point, it's
is a good way to sort of disincentivize people from doing this sort of thing. Like if you're aware of validators doing this sort of shit, and like name and shame them.
Have like
there are other types of like I think there are other types of MEV that are fine if there's like an arbitrage opportunity. Sort of like auctions off that space to people, and it's not necessarily in terms of block space or priority fees. They just like have this MEV tip where they say, give me some percentage of the profit you get from like this ARB.
I wonder actually if it's possible to sandwich people without a mempool. Because if you're maybe, I guess there's no other way of knowing whether something's being locked outside of being the validator. But maybe you could like take a gamble. Just like this is just like naive saying things. But you could like lock, and then you could guess someone's being locked, and then like back run that locked one.
Yeah, I don't know if you need to like care too much about the locking. Like, it's mostly, especially with like new schedulers, just like, am I in the correct priority order to sort of get these things?
Oh yeah, that'd be
in that order.
That'd be a super complex system.
Yeah, you don't know like, hey, what else is in that queue that I don't know about?
Probability stuff, but yeah, again, it'll be so hard to.
I mean, there's like definitely ways I can think of to sandwich users right now. But I think I will not say those publicly.
Okay, because you're already doing it. No, okay.
No, I'm not. Just like there's there are some ways to like see transactions
without being the validator.
Yeah.
Really?
Yeah.
Huh.
Well, I guess yeah. Yeah. I'll just refrain from saying any more here.
Okay, no problem.
I think anyone who is actually like motivated to search would know what I'm talking about, but
Yeah.
it's not worth like exposing something like that, in my opinion.
100%. Well, man, Andrew, it's been a pleasure learning about this new scheduler that you've built. Very informative episode, as predicted at the start. And I'm sure a lot of people would find a lot of value in this. I know I did. But man, it's been a pleasure. Thank you so much for spending your time and sharing your knowledge with us.
Thanks for having me. It was a lot of fun.
And I'm looking forward to using your scheduler.
Me too.
All right, man. Have a good day, and thank you everyone for listening.